Okay. So, we have discussed about the frequency domain parameter extraction and LPC parameter extraction already covered. So, there is a one important parameter which has to be extracted from the fundamental from the speech signal is the fundamental frequency or F0. Sometimes it is referred to pitch extraction, PITCH, pitch extraction, but pitch is not a physical parameter, it is a perceptual parameter. That is why we call F0 extraction, fundamental frequency extraction. Okay. Now, if you think that if you remember that my tube modeling lectures and LPC lectures, so what we said that when human being produce the speech, so there is a vocal tract, that vocal tract transfer function which is Hn, and it is modulated, the input is called glottal excitation. So, glottal excitation, either vocal cord is closed or vocal cord is open. If vocal cord is closed, then there will be vocalic sound or voice sound. So, if it is a voice sound, that can be modeled as a impulse train modulated by a glottal transfer function and then multiply by the gain. Okay. So, when we produce the speech, either speech has a voice segment or unvoiced segment. If it is a voiced speech, then it will be connected to here. If it is an unvoiced speech, then there will be a noise source and it will be connected to here. Then I get the speech signal Sn. Okay. So, now what is F0? So, F0 is part of the vocal cord oscillation. So, if it is vocal cord oscillation, so F0 will be here. The impulse by which we are simulating the vocal cord vibration has a period. So, that period is responsible for fundamental frequency of the speech signal. Now, think about the reverse thing. I want from the Sn to extract F0. I have the voice signal which is recorded. I want to know if it is voiced, what should the input, if it is generated using a impulse response or impulse train, what is the fundamental frequency of the impulse train. Or if you remember the LPC synthesis, from the speech signal, we extracted gain, fundamental frequency and LPC parameters. So, fundamental frequency is required to generate the impulse, by which frequency impulse should be gone through the vocal tract modification, glottal filter and produce that glottal source. So, that fundamental frequency is part of the glottal excitation, it is not part of the vocal tract transfer function. Understand? So, from the pitch or even from the speech signal, how do I find out the fundamental frequency? That is called F0 extraction. F0 extraction has many applications. Mainly when I discuss about the next week speech application, there is a called speech synthesis. There the F0 is a main important part to produce the melody in the speech. Okay. So, when I speak, if you see, when I speak, it is not a robotic voice. If I speak a sentence, the fundamental frequency is changing, it is not fixed all throughout the sentence, fundamental frequency is same. So, suppose I have a speech sentence, not throughout the, if it is 5 second signal, not throughout the 5 second F0 is constant, F0 is moving, that is called fundamental frequency contour. Okay. Now, if I remove this F0 movement from the speech become robotic. So, the melody of the speech communication is F0 is one of the main factor for speech melody. In singing also, if you think about the singing, what is sa re ga ma pa dha ni sa? If you think about sa is the base frequency, next sa is the octave, first octave. So, if it is my base sa is 200 hertz, so sa to sa it is 400 hertz, next sa is 400 hertz, and then this 200 hertz frequency is divided in several scale. If it is sa re ga ma pa dha ni sa, then it is 7 scale, and this can be a uniform or this can be a non-uniform. If it is uniform, then you can say equitemper scale. Okay. Now, if you see that there is a, you can say this, when I say the raga of a speech of a song, or you can rag, different ragas like Bhairavi, rag, so people are saying that you are not touching the upper node, you are missing the node. So, those kind of comment you have seen from that, there is a lot of TV that song competition in the TV channel, and you find that the judges are produce a comment, your upper tone, upper tones are not touching, or you are not touching the upper nodes. What is meaning? So, meaning is that the movement of the F0 is controlled during the production. So, when I singing some song, I am controlling the movement of the F0. So, if it is sa, then there is ni, then sa to ni dha pa ma. So, movement of the F0 is actually defined by that sa re ga ma pa dha ni sa. So, maybe while he moving from lower node to upper node, he may not be touch the upper node, just falling down, because you know sa to sa. So, if is my first sa is 200 hertz, next upper sa must be 400 hertz. So, when I sing, if it is upper sa, then I have to change my fundamental frequency from lower sa to upper sa. Okay. So, fundamental frequency actually responsible for the melody of song. You can say this is the grammar is defined in any song, and also in voice communication, when you talk about, when you speak, it is not always fundamental frequency is same. Fundamental frequency is moving to provide a smoothing communication between human being, unless it will be robotic voice. Then initially people are thinking that fundamental frequency has no use in speech recognition, or maybe they have used the MFCC parameter, whatever we extracted, that is sufficient. But really in modern speech recognition systems, people are thinking that why the fundamental frequency can be used effectively to improve the speech recognition rate. The new dimension is coming, which is called spoken language processing. I will discuss some issue in speech application, spoken language processing, that whatever we are doing ASR, it is not ASR, because spoken language is different from written language. So, those discussion I will come in the next week lectures. Okay. Then speech coding, yes, already we have said that even if basic LPC encoding, F0 has to be provided in the receiver end, because I have to know what should be the F0 of the input impulse, which will to generate that voice signal. So, F0 is very important part for speech coding. Then voice conversion, very important. If you see, this is new technology, that voice conversion, action conversion. Suppose I want, we will discuss details in speech application classes, that suppose that this is my dream, that can I develop a technology, somebody is speaking in American English and I am listening whatever English I am producing. I am not saying speech to speech, I am not saying the English is converted in my mother tongue. I am saying I am converting the same English speech which is spoken by an American speaker to my, and I am listening in my own English, whatever English I am producing, because my English is not American English. Think about a Japanese professor giving a lectures. If I am listening, because I cannot understand the Japanese English that clearly, so my understanding level will be going down. Now, if I able to discover a device that Japanese professor speaking his own accented English, but I am listening in my own accented English, then I think the problem is solved. So, that is the technology we are. So, voice conversion, speech conversion, accent conversion. Then spoken language learning, even if singing, suppose I want that I want computer based singing, learning of singing. So, I can say somebody is singing, there is a guru sing the song. So, he touches the note 1, 2, 3, 4, so all note movements are showing. Now, as a disciple I am singing that same song and computer shown me that okay, you started from here, but your transition from this note to this note taking this much of time and you are not touching this note. So, next time I producing next way, then you are gradually touching the next note. So, that can be used as a tools for learning. Similarly, language learning also. So, suppose that if you say many language has a tone as a phonemes, or I can say the trace as an important parameter for speech clarity. So, those cases F0 is very important. So, there is a numerous application for F0. So, extraction and F0 frequency or fundamental frequency is an important issue, even if not only speech, but also music signal also. Lot of music research is going on, and there also the extraction of the fundamental frequency is very important to find out the movement of the node. So, ragas is defined nothing but a movement of the node. So, you have to find out how the nodes are moving from the signal itself. So, there is a number of problem and number of characteristics also in the fundamental frequency. If it is produced by a human being, then you know the F0 can be varies from 50 Hertz to 400 Hertz. This is a variation of F0. Child speech can have a 400 Hertz frequency. Okay. Now, if you see Fs, if sampling frequency is my 8 kilohertz, let us 8 kilohertz, and if I say that length, if F0 is 50 hertz, then how many samples will be there? How many samples will be there? My F0 is 50 hertz and Fs is 8 kilohertz. So, I can say 8k, 8 into 10 to the power 3 divided by 50. So, it is nothing but 8,000 divided by 50, 160 sample, 160 sample in one F0 period. So, if I say 160 sample, how many millisecond? 80 sample is 10 milliseconds. So, duration if it is 50 hertz, then I have a 20 millisecond duration fundamental frequency. So, if F0, then what is the duration? T0 is nothing but a 1 by F0. 20 millisecond length fundamental length signal is one single F0. Similarly, if you see, if I have a base frequency is 50 hertz, my F0 can varies to up to 100 hertz within a single sentence, can varies, because octave. Second one is 2:1. Next, speech is called quasi periodic. If you see the speech signal, it is not exactly periodic. So, speech signal is not exactly periodic. So, when I generated the speech signal using unit impulse response, the F0 between the two consecutive period is not same. There are some differences is there, and that small differences is called jitter. So, suppose I generate an F0, I have extracted an F0, I cannot say all the F0 value will be same for some segment. The F0 is continuously moving, or there may be a difference. or forward, backward, that kind of variation. So, it is not a smooth F0, it can be look like this kind of F0 contour. So, next frequency, next period it is less, next period it is also, jitter is randomly varying, that is why it is called quasi periodic signal, not exactly periodic signal. Then F0 is influenced by many factors. I cannot say that my F0 will be same for all time. This time I say one sentence, next time if I say same sentence, F0 may not be the same, F0 may be different, because it depends on my emotion, who is doing on emotion analysis or find out the speaker characteristics. F0 has a part. Emotion, most information is communicated by F0 only. Even if you see, if I say spoken language, spoken words and written words are different. If I say the old man and woman, the old, very interesting example, the old man and woman, the old man and woman, if I say the old man and woman, then the man and woman both are old. If I say the old man and woman, man is old, woman is not old. So, in spoken language, if you see the if you recorded it and if you see the F0 movement, you find the F0 define the boundary whether man and woman is roused together, whether the old man and woman, that means man and woman both are old. So, in that case maybe the word boundary will be here, which is called spoken word boundary. Details I will discuss in the prosody, when I do the prosody analysis and prosody, use of prosody information in speech processing in the 8th week lecture. Okay. So, F0 has an important part, but extraction of 0 has a challenge also. If I say I cannot get a purely voice signal, there may be some noise is included. Quasi periodic in nature in speech, difficult to estimate speech with low energy. High F0 can affected by a low formant. Yes, this is very important issues. If you see if you remember, the first formant frequency is in and around 500 Hz. So, it can reduce and it can be goes to 360 Hz also. So, if it is 360 Hz is the first formant frequency, and if F0 is in around 300 Hz. So, F0 can coincide with the first formant frequency, very issue. Next challenging issue is that due to the band limitation, if you remember in telephone speech, we say telephone speech is 300 Hz to 3.5 kilohertz or 4 kilohertz. If it is that, so below 300 Hz, no signal, no component. So, suppose I am speaking over the telephone, my fundamental frequency is 180 Hz. F0 is not present, fundamental frequency is not there, but still receive the fundamental frequency, because the property of fundamental frequency says that the spectral information will repeat. If you plot it, you know this is F0, next will be twice F0 and all the spectral component will be repeated here, next will be thrice F0. So, F0 is not there, but spectral repetition tell me what is the F0 of that signal. So, sometimes this is also important, that if you are looking for the only F0, F0 may not be there, but 2 F0 is there, 3 F0 is there. So, repetition of the spectral information, from there I can find out that I perceive the F0 frequency. Okay. So, if this kind of band limited signal is come, then it is very difficult to find out the F0 also. Okay. So, there is a lot of technique for F0 extraction. From the beginning, there is some time domain methods, some frequency domain methods. So, let us start with some time domain methods. Now, if you remember, during time domain speech processing class, I said zero crossing. Zero crossing. So, we said that if it is a pure sine wave signal, then within a single period signal will cross the zero line 2 times. Okay. So, from that philosophy I can find out the f0 of that signal, f0 by fs, fs by f0, we have calculated that time number of zero crossing per second. So, we can find out the number of zero crossing per second and then I find out the T0 value for which the signal crossed the zero line 2 times. That is called zero crossing based f0 detection. But what is the problem? In this case it is okay. Now, suppose there is a high frequency, this speech is not a monotone signal. So, it is there is a high frequency component. Now, we see the number of zero crossing single, this is the fundamental frequency, but number of zero crossing is changed within one period. I can show you one picture is there. So, in that case I fail to detect the f0. So, zero crossing rate based f0 detection is not a very good solution or good methodology for find out the f0. Okay. But if you see, the detecting of number of zero crossing is the easiest algorithm. So, time complexity of computation of f0 is very less, but it is not at all noise prone. So, I can say method zero crossing detection by the f0 restriction methods is very not that useful, or you can say that is not reliable. Okay. Next technique is called autocorrelation technique, which is mostly used technique for f0 detection. I am not reading the slides, you can read the slides. Okay. Now, what is, if you remember what is autocorrelation? So, suppose this is my signal, think about the pure sine wave. Okay. So, autocorrelation means correlation the signal with itself. So, let us I again draw the same signal. Okay. Now, autocorrelation told me the equation is that R tau is equal to summation of n equal to, let us I am writing in digital domain, or you can say n equal to 0 to n minus 1 x of n plus k. Let us write, instead of tau I write k. Autocorrelation. Okay. Now, for R0, that means if this is my signal, this is my signal, first coefficient is nothing but a product of the all samples. So, like this sample, this sample, this sample multiplied by this sample. So, I get the maximum value. Next time I shifted this signal by one sample in here. So, instead of this signal, my signal will start from here. So, I take this sample with 0 and end the 0 will be padded with the length of the signal. So, what we will get? I will get a autocorrelation coefficient R1 which is less than R0. R2 less than R0. If you see, the signal will come in the in phase when it is reaches here. So, if this much of amount of shift is there, then the 0th sample will be multiplied with 0th sample. Again I get maximum R value. Yes, I get the f0 by 2 also maximum R value, because it is pure sine wave. If it is not pure sine wave, then I will get maxima when the sample is matched exactly with its period. So, if I see that plot, You see this plot. So, if you see, this is my signal and this is my value, R value, R1, R2, R3, R4, R5, R6. Now, if you see at around 50 sample, let us say 45 sample, this again come maxima. Okay, if it is 45 sample, next to also come at 45 plus 45 maxima and 45 plus maxima. So, this is twice F0, this is thrice F0. So, I can say from here to here this 45 sample is the T0. So, what is F0? It is nothing but a 1 by T0. Suppose this signal has a sampling frequency 16 kilohertz, then I can say F0 is nothing but a 16,000 divided by T0. Let us 45 sample. So, let us 50 sample. Hertz. Okay. So, around 300 hertz I can calculate the F0 value. Okay. Now, how we process it? Okay, this procedure is okay. So, how we process it? If you remember that suppose I have a signal, I have recorded my name at 16 kilohertz, 16 bit. Okay. So, my name may be 3.5 second signal. My name is long. So, it may be, let us not 3.5 second, let us 2.5 second signal. So, how many samples are there? 16K plus 16K plus 8K. So, around 40K samples are there, 40,000 samples are there. So, I said when I say my name, the fundamental frequency is not same throughout the signal, it is moving, and also the fundamental frequency only present if the signal is voiced. So, suppose I say Kolkata, let us say Kolkata. If you remember that the manner of the signal, ko is an unvoiced signal, then there will be a burst, then consonant to vowel transition, then steady state vowel O, then O to law is a voiced consonant, then again it will be stop consonant, then again burst, then again vocalic transition, then again it is a stop consonant, then again it will be burst and there will be vocalic transition and again end. So, every vocalic part up to here, this is the vocalic part, I can get F0 value. From here to here, I can get F0 value, and from here to vocalic part, I get the F0 value. Now, how do I know the vocalic part? This is very important part. So, instead of finding out that in signal, what I will do, let us Kolkata is recorded in 0.5 second. So, that means there is a 8K samples are there. Now, I frame the signal 100 frame per second. So, in Kolkata I will get 50 frames signal. So, each of the frame which is duration of 10 millisecond, maybe window by 20 millisecond, will give me a average fundamental frequency value. So, if I extracted that, we take that 20 millisecond window and shifted the window by 10 millisecond, then I get the 100 frame per second. So, for every 100 millisecond, so if I draw the Kolkata in F0 plane, so if it is 3.5 second signal, so there will be a 3.5 second, so 0.5 second, so there will be a 100 frame. So, 0.5 second will be divided by 150 frame. So, every frame is 10 millisecond. For every 10 millisecond, I can calculate a average F0 value for next 10 millisecond. So, I can get the F0 contour which each points are 10 millisecond apart. So, 20 millisecond signal, I will calculate RK value and find out the maxima, first maxima, then calculate the lag, 1 by lag is the F, I can get the F0 value. Okay. So, this is autocorrelation based F0 extraction, very easy, but it is time consuming. Now, if you remember, if you see this signal in autocorrelation F0 extraction, if you see this signal, signal is decaying. RK value, or you can say the RK value plot is decaying. So, it is nothing but a like this way, this way, this way, this way, this way, this way, then this is going down and almost 0. So, I cannot get the first peak and second peak are not equal, it is down. So, detection of peak is very difficult, sometimes may be erroneous also. So, how do I improve this result? I want this decaying should not be there. So, if I want the decaying should not be there, then that is called modified, or you can say the normalized autocorrelation. Normalized autocorrelation. The formula is this one. Instead of calculating the autocorrelation using that R k is equal to n k equal to n equal to 0 to n minus 1 x n x of n plus k, I am calculating different formula, this using this formula. So, this is called normalized cross correlation function instead of autocorrelation. If I calculate R k value, this NCCF, normalized cross correlation function, then if I plot it, if you see, first one is the signal, second one is the normal autocorrelation, third one is NCCF. If you see, the amplitude is not decaying. So, now I can detect the peak easily and calculate the F0 easily. Okay. So, this is called normalized cross correlation based F0 extraction. Okay. So, next class other methods also I will discuss. Okay. Thank you.